All right, let's look at section 4-2, picture this. There are different ways of presenting data. The ones we are going to look at in this section are bar graphs, pie charts, histograms, frequency polygons, and time series. So, bar graphs. It can be displayed as a vertical or horizontal bar graph. You need the data from a frequency distribution. The steps to draw a bar graph are: draw and label the axes. For a vertical bar graph, the type or description, i.e. grades, storms, etc., go on the horizontal axis. The frequencies go on the vertical axis. For a horizontal bar graph, you reverse these two, meaning that in a horizontal, the frequencies, I'll abbreviate, go on the horizontal axis. So, step 2, we will draw vertical or horizontal bars with heights that correspond to the frequencies. It is not correct unless the graph is labeled. You must label the axes. The frequencies are marked off in equal units. If you need to start at a number instead of 0, you need to draw 2 slash marks to indicate this. So we'll take a look at one with those slash marks. Not on this first one, but eventually. So we're using the 25 graded essays from the 4.1 video and handout. So again, this was from the last section. This is what the tally marks look like. The tally marks aren't that important here because we're just going to use the frequency. So again, the frequency is the number of times these grades occurred. So let me zoom out a bit. As we're going to put this, make a little bar graph down here. So you'll want to use some sort of ruler or straight edge. So we have this bar graph. We are making a vertical bar graph, which means that the type or description goes on the horizontal axis. So that will be the grades, the student test grades. You don't want to do it right below the bar because we're going to have to label A, B, C, D, E. Well, no E, but F. And then here, to move the page, are the frequencies. So frequencies on the vertical axis, the description, or the in this case, the test grades, on the horizontal. This is important to note. In a bar graph, the columns do not touch. They do touch in a histogram, which we will look at shortly. So what are our grades? There were students that made an A, students that made a B, students that made a C, a D, and an F. And then our frequencies are really numbers, 1 through 9 here. Well, actually, we will start at 0. Then we go up 1, 2, 3, 4. Go up a bit more. 8. And finally up here, 9. I'm going to draw this as best as I can, but, it's handwritten. It's only going to look so good. So we're taking this information, the grades of our students here, and turning it into a vertical bar graph. So our frequencies go vertically. We label the axis going horizontal. And now we see that 4 students made an A. So I'm going to make a bar like this. And you can color it in if you want. 4 students made an A. And so the column, one of those blanks we filled in for part 2, draw vertical or horizontal bars with heights that correspond to the frequencies. So the height of this bar is at 4, which is how many students made an A. 7 students made a B. So I make my bar. Again, in a bar graph, we do not touch. That's how many students made a B. 9 students made a C. So this column will go all the way to the top. And then D and E will be smaller bars because only 3 students made a D and only 2 students made an F. So there we have it. That is a vertical bar graph. Let's move on. Try this one with talking about eye color and numbers of students. So I want to number all the way to 12. You do have some options here as far as building a graph. My frequencies, so you can label it as frequencies or number of students. We'll make our horizontal line. And again, it is a vertical bar graph, it specifies. That doesn't look like anything, probably. This says number of students. And here we have our eye color. So we're going to have students with blue eyes, students with brown eyes. I did those out of order. That's okay. Green and hazel. And then as we label the vertical axis, I want to start at 0. And then I don't have to number all the way to 12. I can kind of just number the evens. 2, 4, 6, 8, 10, and 12. And that way, if we get an odd number like hazel, we can start there. How many students have hazel eyes? Only 3. So I'm going to go up, halfway between 2 and 4. So that is at 3 if I made kind of a line here. Well, we can see it there. How many students have green eyes? 2. Again, the bars do not touch in a bar graph. How many have blue? 12 students have blue. That's a lot. Here's my blue. And finally, brown. 10 students have brown. Something like that. So now we'll look at a horizontal bar graph. And here we are not going to start at 0. On the previous problems, we started at 0 on the frequency graph or axis. So now, in a horizontal bar graph, my frequencies are on the horizontal axis. That is the change here. So my horizontal axis. And I have a vertical axis. This information is about airports and how many passengers travel through there. And the number we are given is in millions. So this is not just 49.3, that's 49,300,000. So the frequencies go on the bottom axis. So these are the passengers in millions. And then here we have the airports. So now our descriptive axis is going up and down, and our frequencies are going side to side. So now the double bar, let's see, what did that say about double bars? If you need to start at a number instead of 0, you need to draw 2 slash marks to indicate this. So we're not going to start at 0. So we're going to put 2 slash marks like so. Our smallest number here is 27.8 million. So we'll start the numbering at, say, 25. So we need to go from about 25 million to, say, 50 million. So we can go in increments of 5. So 25, 30 million, 35 million, 40 million, 45 million, and finally 50 million. So, these are the airport codes in case you haven't seen them. Every airport has a 3-letter code. And if your abbreviation is only 2 letters, they put an X on the end. So we have the Atlanta airport. We have the Chicago O'Hare, ORD. We have LAX. We have Dallas Fort Worth, DFW. And a little bit cramped here, JFK is one of the airports in New York. So let's start at the top, JFK. 27.8 million. Passengers flew out of JFK. So we start at not really 0, but the double slashes, and we end just past 25 million. And our bars should still not touch. So now we do DFW, which should end a little past 30 million. So there's 30 million. We'll go somewhere around here. Just past 30 million, for that 31.6. Of course, this won't be exact. We're doing just kind of as good as we can. And it really doesn't matter what order these are in, as long as they match the right number. LAX, we had about 36 million. So we'll stop somewhere past the 35, maybe like right there. There's our bar for LAX. For O'Hare, the big airport in Chicago, about 36 million. Almost exactly the same as LAX. 36.3 and 36.4. These should basically match. You can make the larger one go out just a little bit more. But it's a decimal of 1, essentially. And finally, the Atlanta airport, one of the biggest hubs, at just about 50 million. So we'll go almost all the way to the end. And shade it in. So that is it for the bar graphs. And now we'll look at pie charts on the next page. Pie charts. You've seen pie charts. This is another way to display data. To get a precise chart, you will need to use a protractor or Excel. That's one of the projects you'll be doing. If you are going to get an idea of what it looks like, you can estimate the percentages. So we are going to find the percentage of the circle and change it to a decimal and the numbers of degrees corresponding to each slice. To find how many degrees each wedge has, take the percentage in decimal and multiply by 360. So real quick, there are 360 degrees in a circle. We will either, using a protractor or Excel or estimating the degrees, graph each section on the circle using the angles that we calculated. Label the chart so that it is clear what each slice represents. So a little guide here. Let's take a quarter of our circle, cut it into a fourth. We know that a fourth is 25%. So convert percentage, 25% is how many degrees? To figure that out, take 25% as a decimal. So take it as a decimal, and we get 0.25. And then you can multiply that by 360. This is basically saying, what is 25% of 360? Put that in the calculator, and we get 90. 90 degrees is 25% of the circle. What about 50%? We could take 0.5 and multiply that by 360, and we would get 180. So 50% of a circle is 180 degrees. So I'll just freehand this. But if I have a circle and we cut it down the middle, we have 180 degrees in both half. So let's look at our first example. Again, a circle has 360 degrees. For this example, you are given the following information. Carla has a budget of $2,000 a month. Given the following expenses, construct a pie chart. So this is not a cash flow problem like we did earlier in the year. If I add up these values, 900 plus 200 plus 5 plus 150 plus 250, that comes out to $2,000. So the total is $2,000. So let's look at filling out a table to help us visualize this pie chart. Our first expense is rent, and rent is $900. What percentage of our budget of $2,000 is rent? That's easy to find out. Just take 900 and divide by 2,000. We do that, and we get 0.45. So that's 45% of the of our budget. But what is that as an angle? How many degrees? That's what this is asking. An angle is in degrees, like a 90-degree angle. Zoom in here. I don't know if you can read that. That says degrees. So we can take 0.45, remember the decimal 4, and multiply that by 360. And that will give us our degrees, 162 degrees. Next, we have utilities. Utilities is $200 a month. 200 out of 2,000 means that we divide 200 by 2,000, and we get 0.1. Move that decimal twice. You can think about it as 0.10, and we get 10%. How many degrees is that? Well, we take the decimal of 0.10 or 0.1 and multiply by 360 to get 36 degrees. Next is food. That's 500 out of 2,000. That's 0.25 in the calculator, which is 25%. So I know exactly what the food part of this budget is going to look like. That's our food. We'll make a bigger circle on the next page. And I know that should come out to 90 degrees. And sure enough, 0.25 times 360 is 90 degrees. We have transportation, which is 150 out of 2,000, which is 0.075. Move this decimal twice, and we get 7.5%. How many degrees is that? Take the decimal, multiply by 360 to get 27 degrees, which will be kind of hard to draw. Finally, our miscellaneous, everything that's not one of these other four. The remainder of our budget, $250 out of 2,000, gives us 0.125, or 12.5%. What is that as an angle? 0.125 times 360. And that gives us 45 degrees. If I add up all of my percentages, you can put it in the calculator if you don't believe me, but it's 100%. If I added up all of my degrees, 162 plus 36, etc., it comes out to 360 degrees. And that's what every pie chart should come out to. So we're going to use this information on the next page as we construct a pie chart. So again, food is going to be an easy one. Because that's exactly 25%. Rent is 45%. I'm going to jot this off to the side. So again, if it went straight down the middle, that's 50%. So it needs to be a little bit like that, like 1/2 of a peace sign, kind of. So I can't go all the way down for rent, but I need to go a little bit off to the side here, like so. Again, we're just doing this by hand. It won't look that good. What else do we have? Utilities is 10%. So that has to be smaller, about less than half of our 25%. So something like that sized for our utilities at 10%. Which means we have miscellaneous at 12.5% and transportation at 7.5%. So I need to split this remaining section, and that adds up to 20%, and that looks about 20% of the graph that we have left. So I want to make two sections, different sizes, and the bigger section needs to be the 12.5. So maybe something like that. That's probably too big compared to this, but that's okay. We're doing as well as we can. Miscellaneous is 12.5%, and transportation, capital T, 7.5%. If I'm grading a test like this by hand, I'll just look at the smallest percentage needs the smallest part of the pie. The biggest percentage needs the biggest part of the pie. As long as everything else is just a good enough attempt, then we're fine. So now we're going to look at histograms. Histograms. Here the bars do touch. Bar graphs do not. Histograms do. So we have this information about lifespans of animals. And they use this term bin. Determine the bin. In this example, I will use 5 years. So, like a kind of a box or something that you could organize this data into. And we're actually going to use the next page to fill this in. So I'll kind of be going off both pages. So again, the bin is like 5 to 9 years. How many animals live 5 to 9 years? Do we make a tally mark, or no, we're just going to list the frequency. And then how many animals live from 10 to 14 years, 15 to 19, etc. Only one animal lives 5 to 9 years, our friend the bee. So one animal lives for that long. How many animals live from 10 to 14 years? Well, there's the groundhog, the squirrel, the grouse, and the rabbit. Did I miss one? Nope, Mr. Turtle. These are animals that live 10 to 14 years. Oh, sorry. We don't need the pie chart anymore. These live 10 to 14 years. The rabbit, turtle, grouse, squirrel, groundhog. So 5 animals live 10 to 14 years. 15 to 19, I'll just start filling in the frequency, but I don't know what a nutria is, but there's a parrot. Those are the only 2 that are in 15 to 19 years. So put a 2 there. And now you can just believe me that there are 2 animals that live from 20 to 24 years, chinchilla and a teal. 25 to 29 years, 1. No animals lived from 30 to 34 years. 1 lives from 35 to 39, and 2 live 40 to 44. And now we're going to turn this, I don't think I can get the whole thing, but we're going to turn this into a histogram. So I'll just do it back to this bottom section. It looks like a bar graph, pretty similar to a bar graph. We have our average, lifespan in years, and then our vertical column is the frequency. So, let's talk about the bins and how they touch. So I'm going to start with 5 to 9 and then 10 to 14. So we don't need to start at 0. I'm going to start at 5. And then watch what happens. We go in increments of 5. So 5 to 10, to 15, to 20, to 25, 30. Keep going. And we will stop at 45. So 5 to 9 years. We're going to go up to the 10 here. One animal lived from 5. Oh, I'm sorry. I didn't list my frequencies. 1, 2, 3. The biggest number we got here was 5, so we'll go up to, we can go up to 6. So, how many animals lived from 5 to 9 years? And the answer is 1. And so we make this bar right here. Again, in a histogram, they touch. So it's kind of like a less than or equal to 10. They come up to 10, but don't actually reach 10 years old. How many animals lived from 10 to 14? I look at my frequency and I see that it's a frequency of 5. So I'm going to go from here, because they touch, all the way up to 5 and come back down. The table that we filled out told us that 2 animals lived from 15 to 19 years. So that's touching this bar and coming down to the 20. Same thing for 20 to 24 years. I'm going to put some of this over here. Had a frequency of 2. So we start at 20. We go to the next bin and make our column. Next, we had 25 to 29 with a frequency of 1. So we go like that, touching the bar next to us, stopping. I'll try to go right to the left of 30. From 30 to 34 years, we had 0 animals. So we leave this spot blank. But then 35 to 39 had a frequency of 1. So we pick back up after the blank field. And then from 40 to 44 had a frequency of 2. So we go up to 2 and stop at that 5-year bin of 45. So if there's any confusion, like 5 to 9, but we go up to 10, 40 to 44, but we go up to 45. Think about it like 40 years to 44 and 364 days. Like, this animal died 1 day short of its 45th birthday. So the bins are supposed to be in these increments here of 5. And that's why the bars kind of go touch the next bin. There's another one here that you can try on your own. And then the last thing we will look at is section or part D, the time series graph. If you do that previous one on your own, feel free to take a screenshot and send it to me. We can talk about it. So a time series graph, we label the horizontal axis with time units and the vertical axis with a scale beginning at 0. That is appropriate for the data. Or label the axes in a way that is appropriate for the data. Plot the points from the table and connect the dots. So we have the number of bachelor's degrees in thousands issued from these 10-year spans from 60s to the 2000s, with the number of degrees going up each time. So time is always the x-axis. So, and that's what it says. Label the horizontal axis with time units. So the horizontal is time in years. And then might need more room up here. This is number of degrees, and it's in thousands. So that says number of degrees in thousands. We will start. We don't need to do the double bars. I know that's probably confusing, but that's only on the histogram and bar graphs. Here, we're going to start at 1960, go to 1970, 1980, 1990, and 2000. And the number of degrees, well, it's off the page here, but the vertical axis, we want a scale beginning with 0. So the first entry we have for the number of degrees in thousands is 400. And then we're going to go up to about 1200, or 14, I guess. So let's say this is 200, 400. We'll go in increments of 200. It's kind of up to you what increments you want to use. You just want it to be, readable. That's not spaced exactly, but good enough. And now we're basically going to take this table that's above us here and make points. In 1960, there were 400 degrees, 400,000 degrees issued. In 1970, there were 795. So I'm going to go right up to about 800 and put a dot. We'll connect these in a bit. 1980 is 955. So that's, somewhere around here. In 1990, there were 1,020, so above 1,000. And then a bigger jump here. In 2000, we're up at about 1,220. And then we can just connect the dots to make our time series graph. And so this kind of shows the progression in, what about like 1975? Well, it would have been somewhere around here as the line is going up between every decade. So that's it for 4-2. Hope that helps with the homework. Let me know if you have any questions, and I'll see you next time.